Okay, we're back. You're not going to believe what I did. I just explained problem 28 to you, but I had a different screen on that so you couldn't tell, you couldn't see what I was doing. Anyway, here's problem 28 written out. Look, they got the sun here, and they got the moon here, and then they got the earth down here. And we want to find out what is the net force, the net gravitational force. Well, the net force is going to be the force of the sun on the moon times the force of the uh, Earth on the moon, and then it's this resultant vector right here. So the force of the sun on the moon actually becomes your x component squared, plus the force of the Earth on the moon becomes your y component squared, and you take the square roots of them. Now, how do you find the forces though? How do you find the forces? Well, the force, again, g, m of the big object, m2 of the small object, divided by their distance apart. All of this information is given somewhere. You know what g is. G is equal to 6.67 times 10 to the negative 11, one more time, newtons meters squared per kilogram squared, all right? And then they give you the distance for the sun from the moon and the earth from the moon. But what you have to look up is what is the mass of the sun, and what's the mass of the moon, and what's the mass of the earth, and what's the mass of the moon. All right. So when you're figuring FSM, it's this: is G, mass of the sun, mass of the moon. All this is in your appendix of your book over the distance of RSM, and then the Earth and the moon is equal to G times the mass of the Earth, mass of the moon, divided by R EM squared. All right? Sorry I didn't explain those earlier, but we'll use this later on when we look at, in Chapter 5, when we look at radial speeds. The other fun thing would be, if you just wanted to look at this, look at the moon, you could figure out how fast it's going around the Earth by the gravitational forces of the Earth. If you neglected the force on the sun, but the sun seems to be really pulling it. All right, out of here.